1.1 through 1.4. Okay, little review. Syllogism, what is it? Basic form of the deductive argument, the standard form of the deductive argument. This should come quickly off the tongue right now. Hey, do you think that would be a good question to ask on an exam? Might be. Already we've seen that syllogisms have a specific structure. Premises support conclusions. Conclusions get the support of premises or reasons. Premises can be ranked as major and as minor. We looked at three kinds of deductive arguments briefly. We looked at inductive arguments before that, and we're going to take these up in some detail today. Already we played with two key types of syllogisms, modus tollens, which is one of the conditional syllogisms, and it says A, then B, then it asserts not B, and then draws the appropriate conclusion, not A. And the syllogism known as Barbara, which is not a conditional syllogism, but a categorical syllogism, using one of the categories. The categories are all, some, or none. This one is all. And the Barbara syllogism runs all A or B, all C or A, therefore draws the conclusion, all C or B. Now we're going to try to understand what they are and how they work. Furthermore, we're going to explore the various types of syllogisms as a way of expounding what is the single most important and single most difficult concept in deductive logic. And I said this before, and I repeat it now, and I'll repeat it still down the road. The single most important and the single most difficult concept in deductive logic is the concept called validity. And as we'll see, that has a specific definition. It's not the ordinary dictionary definition. We'll put that down. Those who remember introductory philosophy, remember Kant's categories. This may be a little bit familiar, the categorical, the hypothetical, and the disjunctive relation in the table of judgments. If not,
my father made him an offer he couldn't refuse.
What was that?
Luca Brazzi held a gun to his head, and my father assured him that either his brains or his signature would be on the contract.
Okay, from The Godfather. Here is an example of a disjunctive syllogism, one that uses either or. Either your brains or your signature are going on this contract. Right? So the disjunctive syllogism, the first one we're going to look at, but a word of caution, at least qualification, because there are two very different kinds of disjunction. Disjunctive is so called because it expresses a disjunction between two terms, call them A and B. But again, two different ways to do this. And we're going to pick this theme up again when we come to the next chapter, chapter 2, on ordinary language, because ordinary language is typically ambiguous in this sort of way. One word can mean two very different things. Here's an example. Whoever refuses to support school reform through privatization is someone who does not care about our children or is a tool of the fat cat union bosses. But one could be both. One could be both callous and a tool. So here the word or is being used as an inclusive disjunction. It's being used as and or rather than either. Are you male or are you female? Well, in this question, or is being used not as an inclusive, but as an exclusive disjunction. You're either or. You're one or the other. Just as a matter of fact, is being male or female an exclusive disjunction? Well, there's a big argument about that. It's raging at the moment. Disjunction of the exclusive either or sort always run the risk of being false dichotomies. Sometimes they are. Now, there are true dichotomies where an exclusive choice is specified. So this is a basic rule of thought. Nothing can be both A and non-A. For whatever A is, something can't be both that thing and not that thing simultaneously. But there's some other disjunctions of the exclusive either or sort which turn out to be false dichotomies. So the cow has a free choice. The cow can go either left or right. Of course, both lead to the slaughterhouse. Not a real disjunction. Interesting point. Just because I'm wrong doesn't mean you're right. Yes. Now, as to whether there are only two sexes, people argue about this. There's a classic piece in the literature by Anne Fausto Stirring, The Five Sexes. And she says there, yes, male and female, that's about 97, 98% of the population. But in between, there are intersex types. And she divides them into three categories: merm, herm, and firm. Herm stands for hermaphrodite, which is classically been the term used by someone whose genitalia and or endocrine system is ambiguous but skewed toward the female side is affirm, and someone who's ambiguous but skewed toward the male side is affirm. So that gives us 5 possibilities rather than just binary distinction. Regarding gender, it's now fashionable to break down any binary distinction. Some say there are 52 genders, some say there are 112. The relation between sex and gender gets disputed. But questions whether there are 5 rather than 2 or 212 or whatever, questions about gender identity, who's entitled to use which bathroom, these are all substantive content. Because remember, in logic, we're interested primarily in the low substantive form. As we've seen, the statement A or B can mean one or more of 2 things. I mean, either A or B is the case, but not both, or it could be that A or B alone, or both A and B are the case, in which case that would be a statement if only A or B, or if both A and B. The former, number 1, is called the exclusive disjunction because the truth of one term excludes the truth of the other. And the latter, number 2, is called the inclusive disjunction. The difference between exclusive and inclusive disjunction can be illustrated respectively by what are called truth tables. Now, we're not going to spend a lot of time on truth tables in this course. I'll just mention it now for reference. Consider first the inclusive. The only way for the disjunction A or B to be false is if and only if, or IFF, if and only if both A and B are themselves false. Otherwise, A or B inclusively is true when both A and B are true, or when at least one is true, either A or B. So unless both A and B are false, then A or B, would have to be true. Yes, remember if IFF. We've talked about this before. The weak conditional if and the biconditional if and only if. The ordinary weak conditional if is not logically equivalent to converse. That is to say, just because if A then B to the case does not mean that if B then A. But for a biconditional, remember this is rarer, and people have to really spell this out. People say if in ordinary speech. Generally do not mean the biconditional. You have to go out of your way to say that. It's stronger, and it's true if it's true. If we say that if A then B, then it's converse. If B then A, it would have to be true also and false. Consider the exclusive. Any other proposition, it might be true or it might be false. Any other synthetic proposition. A disjunctive statement might conceivably involve the fallacy of false dichotomy, but here or means either or in the exclusive disjunctive. If an exclusive disjunctive proposition is true, then, unlike the inclusive, A and B cannot be true simultaneously. The truth of A excludes the truth of B, so we'll call it exclusive. And same identical chart for B. Okay, if we were to do symbolic logic, which we're not going to do in this course. If you want to study symbolic logic, there's an entire course on that. It's an advanced logic course. And if you're going to be a philosophy major, you will probably take that course at some point. But I think for the average student trying to understand what logic is, the symbolism is not terribly important. That's my take. Other teachers may disagree. But we're not going to do a lot of symbolic logic, any. If we were to do it, we would use the inclusive disjunction. We're going to use the exclusive either or. It's going to be more useful to make the point I'm trying to make here about the different types of syllogism. And you see, if you do the symbolism, use the wedge operator, that's the kind of the exclusive disjunction is found in Aristotle and Kant in the earlier kinds. Okay, so let's use the exclusive disjunction and note that when we have a disjunctive syllogism, we've got a syllogism here, right? 2 premises and a conclusion. The major premise is a disjunction, either A or B, that is the exclusive. For example, we could say major premise, either A or B. For the minor premise, we assert A. Okay, so what are we required to do? Well, logically, the only conclusion we can draw is if it is a case, if it's true that we have to choose A or B, it's either A or B, and it's true that A is the case of B capital. B. Suppose we said, on the other hand, use the same major premise, but we substituted a different minor premise. Suppose this time we say not A. What do we conclude? The we conclude is B. Or suppose we assert B instead of asserting A. Either A or B, B. Therefore, what do we conclude? Not A. And guess what? The last one is going to be If we deny B, then we have to assert A because they are alternatives there. One is true. If one is true, the other is false, then can't both be. Good news. We got only 4 types of disjunctive syllogism. And guess what? Even better news, in a sense, all 4 forms are valid. As long as you understand what your exclusive disjunction means and you're paying attention, you can't go wrong. Whatever you do, whether you assert A or you say you deny A, say not A, whether you assert B or you deny B, say not B, then whatever conclusion you draw appropriately is going to be a validly wrong conclusion. But there's bad news, because for this very reason, the disjunctive is it useful to show the difference between valid and invalid inferences. You can't compare the valid with the invalid ones because there are no invalid ones in this particular type of syllogism. Now we'll see that's not always true in any kind of syllogism. And in fact, we use disjunctive reasoning all the time. If you troubleshoot a car, okay, the car doesn't start. It started yesterday. Well, let's see. The first thing you look at is the tank empty. Okay, people forget to fill their tank with petrol. Well, okay, either it's empty or it's not. If it's yes, if it's empty, then fill the tank. If not, then you go on to something else. Experience tells us electrical system is probably the next most likely cause. If the car ran yesterday, either the starter's bad or the battery's died or there's something wrong with the spark plug, whatever the case may be. So you go through the electrical stuff in order. If that doesn't solve the problem, then you check another system. You just keep on going down the line, process of elimination until you find what the problem is. And that's a very, very common thing. And humans do this all the time, just for the reason that it's next to impossible to go wrong with the disjunctive syllogism. It also doesn't take much formal education to use it either. My mechanic Howard probably never took a logic course. I think he may have graduated high school, but Howard knows Mustangs. I have an old Mustang. He's a whiz at fixing. He knows more than I do about cars in general, and he uses disjunctive troubleshooting all the time, and it works. This fact, in turn, raises an interesting question about logic and psychology. Logicians I mentioned in the first lecture, or the second lecture, assume that logic describes not how psychologically we do think, but instead prescribes in how we ought to think, rather than descriptive. It's possible that even if this point is correct in general, it may be less true of the disjunctive syllogism than of the other syllogisms. Ancient logician Chrysippus gives the example where he had a dog, and he claims that his dog used disjunctive reasoning. There were 3 possible trails down which the prey might have run. So the dog sniffs trail A, no scent. Sniffs trail B, no scent. Doesn't even bother to sniff trail C, he just goes right down it. And Chrysippus takes this as evidence that the dog was reasoning. The animal went either by this road or by that or by the other, but it didn't go by this way or that, therefore he went the other way. Now, this seems to attribute language and thought to the dog. And that could be a problem. Does the dog have cognitive skills? Yes. And we can talk sensibly about cognition in a whole variety of species. Blue jays, for example. Blue jays are very good at figure ground puzzles. Crows are very intelligent, and birds related to crows. Yeah, we can talk about there are people who do cognitive research into bird intelligence. Now, do we want to say that birds or dogs think? Well, that's another problem. If you think that logic depends on language, and that's what most people suspect these days we're going to have to do, well, dogs don't have language. So if dogs don't have language, they're not reasoning logically either, contrary to what Chrysippus thought about his dog. Here's an interesting possibility raised in a recent paper. Perhaps non-linguistic creatures display cognitive activity of a fundamentally different kind than human thought. Proponents may grant that our lower level cognition resembles the mental activity of languageless creatures, but they insist that we also manifest higher level cognition unavailable to such. The main challenge facing such a view is to describe non-linguistic cognitive processes differ in a principled way from higher level human thought. And this is work that still could be done, but it's at least a possibility. We could talk about cognition across a whole range of species and yet not necessarily talk about thinking across that same range. There's an interesting thesis about human cognition and human knowledge called thinking fast, thinking slow. It comes from Tversky and Kahneman, famous body of research. And maybe it's that humans have both system 1 and system 2, but dogs can use disjunctive syllogism only in what we call system one in ourselves, and they can't. Following up on Ricorda's suggestion. Okay, we've looked at the disjunctive syllogism. We've seen that, well, since all the four forms are valid, we can't really use it to pry apart the concept of validity and concept of invalidity. So let's go to another kind of syllogism, the categorical syllogism. And we're just going to touch on this briefly right now because we're going to spend our time in chapter 5 to the very end of the course dealing really with the categoricals for reasons I'll there. Okay, what makes a categorical syllogism is that the major premise is a categorical. What's a categorical? It's a statement that uses either the word all, some, or none. Okay, so if you're talking about all things, some things, or no members of a category, let's say, then you're dealing with a categorical proposition. And actually, in the categorical syllogism, not only is the major premise a categorical, but the minor and the conclusion are too. Just a little aside here, you're going to see this throughout the presentation. Our typical Socrates syllogism: all men are mortal. Socrates is a man, therefore Socrates is mortal. Actually, is a categorical syllogism because it's not grammatical in English, but it's grammatical in English to say Socrates is a man. What we really mean logically is that all members of the category Socrates are members of the category man. So there's an implicit all in these this minor premise and this conclusion, as well as explicitly. So this does technically count as a categorical syllogism, even though we want to English grammatically we seem to be speaking singular. We're really speaking of Socrates as a member of the category Socrates. Well, that minor point we'll come back to. Okay, so the categorical syllogism. How many forms of the disjunctive syllogism did we see? There were only 4, if you recall. Okay, how many forms of the categorical syllogism are there? Well, a bigger number, 256. Yes, 256. The bad news here is there are way too many categoricals to demonstrate that easily the difference between valid and invalid forms. So, we're going to leave this for chapter 5. When we come to do Venn diagrams, they'll be useful in sorting out validity, invalidity, categoricals. And that brings us to yet another kind of syllogism, conditional. There are only 4 disjunctives, but they're all valid, so that we can't show the contrast between valid and invalid. There are 256 categoricals, and depending on how you construe it, either 15 or 24 of them are valid. So a very small minority of the categoricals are valid, whereas all of the disjunctives are. But still, 256, way too many to manage the contrast. So the third sort of syllogism, the conditional, can this help us out here? And yes, it can, because like the disjunctive, there are only 4 conditional forms, but unlike the disjunctive, only 2 of them are valid, and the other 2 are invalid. So here we can show with a fairly small number 4 difference between valid and invalid types. It's kind of like Goldilocks and the 3 bears, the 3 Israeli bears. The disjunctive is too soft, the categorical is too hard, but the conditional is just right. Now, we're going to restrict the name conditional specifically to the syllogism which has a conditional statement only for its major premise. There are also hypothetical syllogisms, and Mr. Hurley treats these formally as he should, as special cases of the conditional. A pure hypothetical syllogism has conditionals not only in the major premise, but in the minor premise as well. And so you get things like this: if A, then B; if B, then C; if A, then C. And you string together one condition leads to another, etc. If I work hard, I'll get good grades. If I get good grades, I'll go to a top college. If I go to a top college, I'll get a great job. If I get a great job, I'll make a lot of money. If I make a lot of money, everybody will hate me. That's why I didn't do my homework. Hypothetical syllogism doesn't assert that A is the truth, it's the case, or B is the case, or C is the case. It merely says that if the premises are true, then this condition follows. So it's not actually, it's kind of weird, and the conclusion doesn't state a fact, but it is related to the conditional in this way. We're going to just confine ourselves to the simple conditional, because that is going to show us how we can sort out valid from invalid. In the pure conditional syllogism, the major premise is a conditional statement. What's a conditional statement? Well, It's an if-then statement. I talked about that before. But let's break this apart a little more. Notice we're using letters A and B. They're just placeholders. But the conditional statement says, if A is the case, then B is the case, okay? And we give names to these two bits. A bit, the first bit, we call the antecedent because guess what? It comes before. And B is called the consequent. It follows after. Now, simple terminology, but very important. Keep this in mind, memorize these terms because we're going to be using them over and over again. Now, when we have a conditional for the major premise, we have two choices. We can either assert or deny, and we can make this choice with respect to two bits, either the antecedent or the consequent. So, for example, let's start with a conditional syllogism. We have a major premise, if A, then B, and this time we're going to assert rather than deny, and we're going to work on the antecedent rather than the consequent. So, the antecedent is A bit, and what are we going to do? We're going to assert it. We're going to say it is the case. So, major premise, if A, then B, minor premise says A. And if we assert the antecedent in this way, what happens? Well, given what the conditional tells us, there's only one conclusion we can draw. Major premise says if A, then B is the case. A is the case, therefore what? B has to be the case. It's the only conclusion possible concerning A in the face of that condition. All right, suppose instead of A, we assert B, as in the right-hand example in the red box. What do we conclude? We conclude A. Well, what if instead of asserting, we deny? What if we deny A rather than asserting A? Then our conclusion is to deny B. And guess what? Fourth one, if we deny the consequent, the B bit, then we deny the antecedent, the A bit. Those are four possibilities. Are there any more? Now, here we can use our Punnett square, cross-classify the antecedent bit and the consequent bit with the two operations we can do affirm or deny, and we get four different options. Of those four options, we give two of them Latin names. The upper left hand we call modus ponens. The bottom right hand we call modus tollens. Latin for the method of putting on the one hand and the method of taking on the other hand. I put it to you that A for the minor premise, upper left, and I take from you B, as it were, the bottom right tollens. Now, these are the two valid ones. In your notes. Modus ponens and modus tollens are the two valid out of the four conditional syllogisms. What are the invalid ones? Remaining two. Asserting the consequent and denying the antecedent. So the upper right hand, we see what's our minor premise do? It asserts B, B is the consequent. It says B is the case. Bottom left hand, what does the minor premise do? It denies the antecedent. It says not A. And so it's as you can see, the names of these types get their names from whatever you do in the minor premise. Why do we give Latin names to the valid ones and English names to the invalid? By the way, we call them the two invalid ones. We call them the fallacy of asserting the consequent or denying the antecedent. Fallacy means validity. Well, we could just as well give English names to the other two. Just kind of helps to remember that the two Latin ones are the valid ones. But we could describe modus ponens in the same way we describe the fallacies by what the minor premise does. So, what does modus ponens do? We'll look at the minor premise number two. It asserts the antecedent. It says A. A is the antecedent bit, and it makes an assertion. And down to the bottom right, what does modus tollens do in the minor premise? It denies the consequent. What is B? It says not B. Yes, we could give English names to all four. Again, modus ponens and modus tollens are the valid ones. The fallacies are the invalid. You mean to tell me that modus ponens and modus tollens are the only valid conditional syllogisms? Yep. Okay, let me repeat. What is the single most important and the single most difficult concept in deductive logic? And validity. Let's look at validity. Validity is a term of art in logic. Term of art is something that comes from law. It's a term which is used in a technical sense that the term doesn't have in ordinary language, not the first thing you would find in the dictionary, but a specific usage. And different academic disciplines have sometimes different terms of art. This one is a term of art, definitely in logic. in that if you look up validity in the English dictionary, the first definition is not going to help lead you down the line. The term validity gets used in another term of art way, a rather different way. We use the term valid in ordinary speech in a rather different way. Logicians want to use it in a very, very specific. And here's the definition. I said I would define it for you down the road. Well, here we are down the road. Okay, you want this in your notes. Validity is that property of a deductive argument such that if and only if, remember, two things happen. If the form of the argument is valid and all relevant premises are true, then the conclusion can never be false. The conclusion must necessarily be true. Now, before we go on, notice what this does say and notice what this does not say. That if and only if is important. What this says is as long as you meet those two conditions, as long as the validity holds and the premises are true, that's when the conclusion can never be false. Does this statement say that the conclusion of a deductive argument can never be false? No, it doesn't. Because the conclusion of a deductive argument can sometimes be false, but it will only be false if you don't meet those two conditions. If your argument form is, if it's not both the case that your argument form is valid and the premises are true, then all bets are off. Your conclusion could be true, it could be false. But as long as you meet those two conditions for validity, if and only if the form of the argument is valid and all relevant premises are true, and that's when you guarantee that your conclusion can never be false. It must necessarily be true. It is as true, is certainly true as the premise. So that if condition is very important couplet. Both and, not an either or situation. Validity is not the same thing as truth. They are two separate conditions. We're going to have to spell this out. However, they are equally important and they need to coordinate. In order to guarantee that a syllogism produces a true conclusion, you have to have both. You have to have both true premises and a valid form. It's a matter of content of statements. Recall, statements are sentences which are either true or false. They have value. Validity, though, is a matter of form. Validity is your skeleton. One interesting consequence of validity being this formal is the following. There is no attempt to supply a separate test of validity for each argument having a distinct content. In other words, validity economizes. If we determine an argument to be invalid, once we've done this for any argument form whatsoever, we don't have to worry about it, the distinct content or the truth value of its conclusions. If an argument form is invalid, that's it, because we know that no matter if the premises are true, you're not guaranteed that the conclusion will be either true or false. So you don't have to analyze each and every single argument for content that you come across, as long as you understand the form and whether that form is either valid or invalid. And that's the first question. We have a rule down the road. We'll see. Analyze validity first and truth. Okay. So having now defined validity, let's defocalize on truth for a moment and focus on understanding validity. Again, repeat the definition. This should be in your notes. This should be committed to memory. Validity is that property of a deductive argument such that if and only if the form of the argument is valid and all relevant premises are true, then conclusion can never be false. Conclusion must necessarily be true. Peter Strawson has an interesting way of putting this. A deductive argument is a sort of threat. It takes the form. If you accept these premises as true, then you must accept the conclusion as true as well, on pain of self-contradiction, as long as it's valid. So validity is a matter of logical force or compulsion. Remember earlier I talked about Socrates saying that knowledge is, of course, in its own right, not a slave to be kicked around by other things. Strawson is making more or less the same point here. There is a compulsion to validity. You have a valid form and your premises are true, you are compelled to the conclusion that follows, whatever it may be. But again, be very careful and precise about what this validity claim means. Ask yourself the question, is it ever possible for the conclusion of a deductive argument to be false? And you should have gathered by now the answer to that's going to be yes. It is possible. If the form is invalid, then true premises can produce a true conclusion or a false conclusion. If the form is invalid, false premises may produce a true conclusion Even if the form is valid, not invalid, false premises may produce a false. You mean that an argument could be valid and still the conclusion can be false? The answer to that is yes. If the form is invalid, true premises can give you a true or false conclusion. False premises can give you a true or false conclusion. Form is valid, false premises may produce a true or false conclusion. But this is the important point. If the form is valid and the premises are true, then the conclusion can only be true, never false. This point is highly counterintuitive. Nonetheless, it is true. Yes, a valid argument can still yield a false conclusion, with only this one exception. It can never do so as long as the relevant premises are also true. Otherwise, it can't. We're off. Okay. Told you the single most important concept is validity. What's the most important page in this expensive textbook? I give you the full edition cover, but it applies to the full edition as well. Answer, page 47, table 1.1. Let's spend some time looking at this. Now, this is a kind of a Punnett diagram, like the square Punnett rectangle, if you will. Look what's being cross-classified here. In the columns, you have valid and invalid arguments and examples, substantive examples given each except for one, as we'll see. Then in the rows, you have permutations of true and false premises and conclusions. So in the first row, what happens when the premises are true and the conclusion is true? In the second row, what happens when the premises are true but the conclusion is false? In the third row, what happens when the premises are false but the conclusion is true? And in the fourth row, what happens when both premises are false? All 8 possible permutations of valid and invalid, true premises and false premises. That's why we had 8 cells on the table. Notice that there's one blank. There's one blank box. 7 examples can occur and only one is ruled out. What's ruled out is the combination of having a valid form, true premises, and a false conclusion. No examples exist. Bigger one. We can give examples for all the other 7. No examples can be given for that box, which combines true premises and valid form. There are no examples possible for that. Of the 8 possible permutations then resulting from the combination, 6 of them are unsound. We'll come back to soundness in a minute, circled in red. 1 of them is impossible. That's the aqua square or rectangle. And only 1 is sound. That's the green circle. So sound argument is kind of hard to come by. You know, you have out of every 8 possible examples, only 1 out of those 8 possible examples found, and of course, 1 out of 7. Kind of meets the 9th edition. The current edition, the one we're using, uses flowers and plants, and the other one used to use wines and beverages. Notice that the form of the argument for the 3 valid examples is the same form, and the form for the invalid examples is also identical in all 4 cases. We've got the all men are mortal Socrates, kind of the Barbara one that we recognize for the valid, and the Michael Phelps fish swimmer thing for the invalid. And if you look, the form is the same. The Socrates Barbara example, all A or B, all C or A, all C or B. You can go through and mark A, B, and C on 3 of those examples of it, and you can see they all work out. Okay? You could likewise see that the form of the Michael Phelps syllogism is all A or B, all C or B, all C or A. And if you can mark the A's, B's, and C's on the 4 examples there, you'd find them they all fit. Notice something else about table 1.1. Shows that there are different ways in which an argument might be unsound. One way in which it could be unsound is if the form is invalid, so all the ones marked blue. Another way in which it could be unsound has not to do with form, but with content. Premises may not be true. So if premises are false, that's the yellow. And of course, an argument can be unsound in both ways. The cells right are both invalid and also have false premises. Okay. As the table shows, if the argument is not unsound on either or both grounds, then it is sound, where soundness is defined once again as having a valid form plus three premises. Again, validity of form is not the same thing as truth of content. To get a good deductive argument, it's necessary to have both. And whenever you do get a coordination between validity and form and the truth of content, then a third property emerges, and that's the one we call soundness. A sound argument is one which has both a valid form and true premise. Now, a good deductive argument then must meet two requirements. The form of the argument has to be valid, the statements and the premises are true, and if those two conditions are met, the argument is sound. So we've already seen, by definition, statements are going to be true or false. That's what makes a statement. A statement is a sentence which has truth value. It's either true or false. So you can say, this statement is true or that statement is false, and you're on track. Deductive arguments, on the other hand, are not true or false. They are either valid or invalid. Okay, and the invalid ones are always going to be unsound, but of the valid ones, some of them are going to be unsound, some of them are going to be sound. So soundness is a much more category, and it applies only to valid arguments, but only to some valid arguments, not to all of them. And it is arguments which are valid or invalid in statements which are true and false. Be careful you don't mix that up. Question: can a statement ever be valid? No, it can't. And you hear people say, oh, that's a valid statement, when they probably mean, what you're saying is true, or I agree with you. When you hear someone say that, you do like Mr. Khrushchev did, United Nations, you take your shoe off and you bang it on the table and say, yep, yep, yep. This is a misuse of language. A statement can never be valid. No such thing as a valid statement. There are true statements and false statements. That's true. There are valid forms and invalid forms. That's also true. Valid statements. So, check engine light should come on, catch yourself down that road. Don't. Okay. Validity. How do we discover validity? Well, there are tests we can do, as it turns out. And the test we can do, the main test we can do, follows directly from our definition of what validity is. Let's review that again. Validity is that property of a deductive argument such that if and only if the form of the argument is valid and all relevant premises are true, then the conclusion can never be false. The conclusion must be true. Okay. Question. Given that definition, if I can supply true premises and still derive a false conclusion, what do I know? Well, what I know is the form of the argument that does this has to be an invalid form. The only permutation allowing true premises to produce a false conclusion is one with an invalid form. So the aqua rectangle there picks that out, but notice right to the left of that, there's a blank space. True premises and a false conclusion can never occur if your form is valid. If you have that combination, if you get true premises producing a false conclusion, then you know that argument can only be an invalid one. Whereas if you have true premises and a true conclusion, you might get that result with an invalid argument as well as a valid argument. And if you have false premises and a true conclusion, you might get that with a valid argument as well as an invalid argument. And likewise, false premises and false conclusions, yes, can be produced also by a valid argument as well as an invalid argument. One thing that's ruled out, which is the power of the concept of validity, the one thing that's ruled out, just cannot possibly happen, is to get a valid argument and still plug in true premises and crank out a false conclusion. Never, 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 never. So, therefore, this is your test from the definition. If you find a syllogism and you can plug in, validity you don't know yet, you can plug in true premises and make it crank out a false conclusion. What do you know? Well, you've just tested and you've shown that that particular syllogism is invalid, is not valid. So, by process of elimination, only invalid forms can produce either true or false conclusions from true premises. Therefore, any form that fails to yield false conclusions but only yields true conclusions can't be valid. So this test is a direct consequence of our definition of validity. And, think about the asymmetry that Popper pointed out. We talked about this in the lecture. No amount of positive instances can prove an argument form valid, But it only takes that one dreaded counterexample to prove the argument to be invalid. And once you've shown that an argument is invalid, it's always invalid. So again, you don't have to test each and every argument every time it comes up. If you recognize an argument form, you've established that that's invalid. You say, I recognize that bad boy. And, once invalid, always invalid. So I'm not going to worry anymore about this argument. I know it's not going to take me anywhere I want to go. So from this point on, you no longer need to take just my word for it. Remember in the past, I've said, trust me, Barbara's a valid one, modus ponens is a valid one. I'll show you down the road. But now we're down the road. You can test validity for yourself. And we're going to work through that now. What exactly entitles us to say that modus ponens and modus tollens, for example, are valid, but also that asserting the consequent and denying the antecedent are invalid? Let's use some conditionals to test for validity. And we're going to use a wet dog, as our example. Okay, let's set up some conditional syllogisms in which we know the premises are true. Why? Because if we know we have two premises and we crank out a false conclusion from those premises, what do we know? We know that only an invalid argument is going to do that. Therefore, we've shown that the argument is invalid. That's the test. So let's say if it is raining, then my dog is wet. The antecedent is it is raining, and my dog is wet is the consequent. There's my conditional statement. And then let's say in the minor premise, I'm going to assert the antecedent, it is raining, and I'm going to conclude the consequent. Okay, so we can formalize that on the right hand without all the words. We just say if A, then B, A, therefore B. Abbreviated form on the right is exactly the same form that you find in the more elaborate verbal form on the left. Okay, now in order to make this test work, we're going to have to stipulate that the major premise is true. Is it always true that dogs get wet when it rains? Well, no, not always. What if the dog can take shelter, go run under the porch or something on that order? But we're going to stipulate this is my dog. Okay, and my dog lives in the backyard, and we don't have a porch, we don't have a doghouse, we don't have a shed, we don't have a tree, we don't have anything under which the dog can shelter to rain. So guess what? Poor dog, my dog, whenever it rains, he gets wet. Okay, so I'm going to stipulate that that proposition is true in order that we can see if we can from it. Must the statement, if it's raining, my dog is wet, be always true? No, it might be false. In fact, the antecedent is, if in fact the antecedent is true, but the consequent is false, it's raining, but my dog remains dry, then this is not true. But let's just ignore this now. Now, the test is not going to work if the premises are not true, since again, think about table 1.1. False premises can produce either true or false conclusion, both valid and invalid forms. So false premises are not going to sort out valid or invalid, like true premises are going to. So if the major premise is true and the minor premise is true, is it even possible that the conclusion could be false? Is it possible, given those two things, that my dog could be not wet? Well, no. If both premises in this example are true, then it is impossible the conclusion could be false. It's impossible the dog could be dry. The dog is wet of logical necessity. So we've tested this one for validity. We tested it for invalidity. Actually, we found that it's not yet invalid. That's all that valid means. Remember, the black swan example, around the corner, there might be another black swan. We might at some point, even though people have played with modus ponens for centuries now, maybe you're going to be the one who discovers for the first time ever in human history a true premises, a false conclusion with modus ponens, in which case you're going to be a professor of philosophy. Write that up, send it into a journal. You'll be famous. Not likely, given the fact that so many people have played with it for so many years and tried, and nobody's been able to do it. But more or less, we can show that these true premises produce a false conclusion. We're going to take it as if it were valid. Valid means not yet shown to be invalid. Well, here we've failed to show that this one is invalid, so we're going to say, for the moment at least, it's valid. And that's the sense of validity. Now, suppose in the second example, instead of making the premise assert A, the minor premise, I make it assert B instead. Okay? Whenever my dog is wet, must it be raining as a matter of necessity? So this example says, if it is raining, then my dog is wet, and my dog is wet, therefore it's raining. Could that be false? Could that conclusion be false? Could the premises both be true and the conclusion be false? Well, yes. Suppose the neighbors are having a water fight with water balloons and one of them gets my dog. Okay, yeah, the dog's wet, but it's not raining. So it could be false that it's raining even though my dog is wet. The conclusion is not necessarily true, but a valid argument is never going to do this. Therefore, what do we know? We know that this one is invalid. This was definitively invalid. It's always invalid. By the way, whenever you encounter this argument again in any circumstance, whether it has to do with dogs and wetness or whatever the content is, whenever you encounter this form, F4. All right, let's go on to the third example. Suppose I say if it's raining, my dog is wet, and that's true, but it's true that it's not raining. Is it true that my dog is not wet? Can it be false that my dog is not wet? Could both premises be true and the conclusion be false? Yes, once again, even if it's not raining, my dog could still be wet. My dog is not wet could be false. So this one also is an invalid argument. And then let's go to the fourth one. If it's raining and my dog is wet, but my dog is not wet, can I conclude that it is not raining? Is it possible for that conclusion to be false, even when those premises are true? And the answer is no. The conclusion, therefore, is necessarily true. Therefore, the argument is valid, not yet invalid, but that amounts to valid. So what modus tollens does distinctively is to deny the B term the consequence, not B, not the case. B is false. This is what happens to any hypothesis when one provides a counterexample. The hypothesis states conditionally A happens, A is the case, then B happens, B is the case, if A happens. But the counterexample chose not B, so A could be ruled out. But it's we're going to come back to this again and again. Karl Popper makes a great deal of this, as you can see, the whole critique of induction based on the properties of modus tollens. And I'm going to go on to say down the road, modus tollens is the single most common deductive fallacy, but we'll see why. Notice that, go back to our four examples. It's possible for both premises to be true, and yet for the conclusion to be false in two of them. And those, when that happens, the form in question has failed the test of validity, invalid. So you can see those two. And there are two others which we've failed to make it fail, so to say, not yet invalid. We take those two to be the valid ones, not yet invalid. Okay, so that's formally how you do it, how you apply the test. The test itself is just a straightforward application of the definition of validity. If and only if the premises are true and the form is valid, then the conclusion can never be false. So you can take true premises and make the conclusion, generate a conclusion that's false. You've shown that it's not, in fact, valid. It doesn't meet those two conditions. And that's a formal way to do it. And that's by the way, that's something you should get under your belts. Do you think this would be on an exam? Probably so. It's an important skill. Now, in a way, though, this is all just kind of common sense. So far, we've looked at a technical demonstration of why, given what a conditional statement says, that certain operations on certain parts of the conditional will always necessarily produce a true conclusion. And that's why these are identified as valid moves, and the others, of course, are not. But if you think about the issue, is really just kind of commonsensical. Remember, unless you're told explicitly otherwise, when you hear a conditional statement, think about it as a weak conditional rather than a biconditional. Weak conditional, it says, if A then B, and the converse would also be true. But the weak conditional only says, well, A is one condition for B to happen, but it might not be the only one. Maybe if A then B is true, and also if C then B is true, and if B then B is true, and if E then, and a whole host of these other things, gamma, phi, psi, etc. There might be a number of things that are causing A. There are conditions, but the one condition you state is not the one and only, not necessary and sufficient. Biconditional. With an ordinary weak conditional, that if A then B does not imply if B then A, like in the strong conditional, like in the biconditional. If it's raining, the dog will definitely be wet, yes, but just because the dog is wet doesn't mean it's just because of rain. It could be because of something else. Likewise, if my dog is not wet, I can be sure it's not raining, and none of the other possible causes either. But just because it's not raining doesn't mean my dog is not wet through other causes. Okay. How could my dog get wet? Well, it could be raining, or somebody could squirt him with a garden hose, or another dog could piss on him, or the neighbors could be having water wars with balloons, and all kinds of things can happen. Given all the possible causes for dog wetness, just to rule out one of those causes, it's not necessarily to rule out the effect. It could be other cause that same effect. Why denying the antecedent is going not to be valid. However, if you rule out the effect, you automatically rule out each and every one of the possible causes. So if my dog is not wet, none of the things, including the raining, got the dog wet, and actually it's not. You have a dry dog. And if you rule in any single one of the possible causes, then you rule in the effect. So if it's raining, my dog is wet, and it's raining, my dog will be wet. But if the hose is turned on the dog, then the dog is wet. And if the other dog pisses on the dog, then the dog is wet. And if the neighbors throw a water balloon, the dog is wet. Given all the possible causes of dog wetness, just to rule in the effect does not specify which of the many possible causes get ruled in. And that's a commonsensical view. Now let's look at the issue of validity with respect to conditionals in yet another technical political manner. Our Punnett square again. Why are there exactly 4 forms of the conditional syllogism? Well, do the math. 2 times 2 equals 4. You take 2 bits of the conditional. What are those 2 bits? You should memorize this at this point. Antecedent and consequent. And what are the 2 operations? You can affirm or deny either of those 2 bits. So that's square. And you can see we can put each one of those 4 different types of conditional syllogism into one cell of the Punnett square, respectively, and the cross classification describes them. So modus ponens up in the upper right is affirming the antecedent. And what happens if you cross classify denying the consequent? You get modus tollens, so on and so forth. Now, notice the property of this Punnett square. Valid and the invalid forms are crosswise. Valid forms are upper right, lower left. Invalid forms upper left, lower right. This produces a mnemonic device and a recipe. Here's the recipe. Take 2 parts of the conditional, they are. Take 2 operations, we know what they are. I'm going to give you the empirical rule I just mentioned a moment ago. Affirming the consequent is the single most common deductive fallacy. And valid and invalid are crosswise. Now, if I gave you that recipe, is there anyone that could not, on an exam, let's say, reconstruct this Punnett square? I'll bet you, as long as you have those 4. And I would, I might possibly, I wouldn't ask you to memorize the 4 bits of the recipe, but if I gave you those 4, you should be able to reason it out and draw just what you see right here from those 4 rules. Okay. Also, possibly as a mnemonic device, you can pop this up here. This is how I do it. When I try to remember what's valid and invalid in conditionals, I just, that little picture comes up in my head. And, oh, yeah, right. I visualize. Okay. That brings us to another test for validity. This is the universal test. It's called substitution. So far, we've used conditionals to explore validity of our Israeli pairs. The 4 with 2 valid, 2 invalid, just right. The 4 with all valid, 2 soft, and the 256 hard. Using conditionals, we define validity, taken as a definition of, then taken, that definition of validity and turned it into a test of validity. We've done this by using the method on our example. This method is going to work for categoricals as well. It's general and universal. The specific way of applying counterexamples is known as substitution. First of all, you take an argument whose structure and truth value is not clear, place it in a syllogistic form using letters as placeholders. We're using A, B's, and C's right now. When we come to chapter 5, we're going to switch to SP and to M for reasons that will become clear there. It really, at one point, doesn't matter what you use. Then, very importantly, for your placeholders, abstract placeholders, substitute dog and cat's verbal examples clearly are true, and then do the basic test of validity. See if you can make true premises yield a false conclusion. Okay. For our placeholders, again, we don't worry too much about what we use. kid says to his math teacher, just a darn minute. Yesterday you said x equals 2. Now you're telling me x equals 3. Well, good. Not important. Own right. And use dogs and cats examples. Mr. Hurley recommends this. I also ended. All mammals are, all cats are mammals, that sort of thing. No mammals are fish. They're pretty obviously true or false statements. And that will make clarity, basically. What we did for dog witness, we took various forms of the conditional, put in substantively true premises, and attempt to make them yield a false conclusion. We went from the argument in speech order. It's raining, my dog is wet, therefore it's raining. We put that speech order into logical order with content easily arranged into a syllogism, reduced to its skeletal form. You get A's, B's, C's, or A's and B's, or C's appropriate. And you can do this in either direction. You can go from the verbal formulation of the syllogism to the abstract. You can go from the abstract to the verbal versa. This time I'm going to start from a verbal formulation in speech order whose content is not clear. It's okay. Put it in logical order of its spare skeletal form and the syllogism. I'm going to do furthermore, not with a conditional syllogism this time, but with a categorical syllogism. Because I want to illustrate to you that the substitution instances do indeed constitute a universal test of validity. Okay, so suppose we say all Adlers are Bobkins, all Krantz are Adlers, therefore all Krantz are Bobkins. Is that true? What does that even mean? We can't tell truth and false unless we know what the terms refer to. We don't know what Krant, Bobkin, or Adler is. But if the meaning of the term is opaque and we don't know the truth value of any of the statements, how can we even decide if the argument is valid or not? Well, as it turns out, it's possible to judge this when the truth value of the conclusion is not clear, even when the basic terms are not clear. Why? Because if we focus on the form and substitute other clearer content with the exact same identical form, then we can see that it can be made to yield a false conclusion from it. So let's start with our Adlers, Bobkins, and Krantz. Here we go in a syllogistic form with the words, content. All Adlers are Bobkins, all Krantz are Adlers, all Krantz are Bobkins, and conveniently we start with A, B, and C. So we're going to make our letters A, B, and C. Let's see how those are the equivalent forms. All A or B, all Adlers are Bobkins. All C or A, all Krantz are Adlers. All C or B, all Krantz are Bobkins. By the way, I mentioned A's, B's, and C's. Notice there's a crucial difference here between the categorical and the conditional. How many terms does the conditional have? Just 2, A's and B, A and B. How many terms does the categorical have? 3, A, B, and C. So check engine light should come on. If you find yourself, and by the way, you need to work these out before the exam. You need to work some syllogisms through. I'll come back to this point presently. I'll show you what happens when you don't. If you find yourself sticking the letter C in a conditional syllogism, you got a problem. If you find yourself sticking in letters D, E, F, and G, or whatever, more than 3 in any of the syllogisms, problem. Okay, so pay attention to that. Be aware. If you're dealing with a conditional, you got 2 terms, antecedent and consequent, and with a categorical, 3. Okay, back to our reduction substitution instance. We're going from content to clear form. And now we're going to go from that clear form and turn to content. We're going to substitute some other content. We're going to do dogs and cats. So all A or B, all C or A, therefore all C or B. We can reduce to, well, any variety of substantive. Let's just use this one. All dogs are mammals, all A or B. All Fidos, all creatures named Fido are dogs, all C's are A, and all Fidos are mammals, all C's are B. Okay, well, let's see. Are the premises true? All dogs are mammals. Yeah, that's true. And let's just say, for simplicity's sake, Fido is a dog's name. Anybody named Fido is a dog. Well, if any Fido is a dog and all dogs are mammals, then any Fido is a mammal. So we've taken our true premises and made them produce a true conclusion. So we have failed to fail the test for validity. We'll say this syllogism is not yet invalid. It's valid. So our Adlers, Bobkins, and Krantz turns out to be a valid syllogism, even though we can't tell just by looking at the content. The content is opaque, but we can change the content systematically, and we can see it a little more clearly. These three argument forms, these three syllogisms, are structurally, formally identical. They're the same one. The A, all A's are B, all C's are A, all C's are B, is the same one in the Adler's and Bobkin's example and the mammals and phytos. And this turns out to be our old friend Barbara. All men are mortal, Socrates is a man, same one there. Still don't know what crowds are, etc., etc. It's true somehow that all Adlers are Bobkins. And if it's true that all Krafts are Adlers, then it cannot be false that all Krafts are Bobkins. Because false cannot emerge from true premises. So there's nothing wrong with the formal reasoning process here, although we don't, again, kind of unclear about what these are. Okay, step one, take an unknown syllogism, or Adler's, Bobkins, and Krafts. Step two, reduce it to skeletal form, A's, B's, and C's. And step three, put in our dogs and cats examples. And then step four, you've made true premises, produces false conclusion, but we've changed to Adler, Bobkin. Therefore, this one fails the test for validity, no matter, again, what Adler's and so Adler's, Bobkins, and Krafts, again, notice this time the minor premise is different from the one we used before. That's what makes invalid, the other one valid, okay? The previous example had a valid form. What about this example? Well, all cats are mammals, all dogs are mammals, therefore all dogs are cats. We've taken this form, the one in step two, given it dogs and cats examples, made true premises, produced false conclusions. So that's different from the other Adler's, Bobkins, so we used earlier. True premises produce a false conclusion, therefore the form fails the test for validity. Again, no matter what Adlers are, we don't need to know that. Here's another example. All college professors are teachers, so all teachers are educators, since all college professors are educators. Okay, here we have speech order rather than logical order. So we're looking for our indicator words, trying to symbolize it in logical order, and we have basically, we have the word so, which is a therefore word, and we have the word since, which is a because word. So our major premise, all college professors are teachers. We'll let C be college professors, T be educators. So we have all C are T. And then since all college professors are educators is another premise. So all C are E. And then therefore, so all teachers are educators, all T. Well, you might want to substitute if you want to put in the A's, B's, and C's, if that helps, you can do that, but you really have the same form, just different letters. Now, what kinds of dogs and cats examples will make the premises true? Okay, suppose we let C stand for animals, E stand for mammals, T stand for cats. Then what do we get? All animals are cats, all animals are mammals, therefore all cats are mammals. Well, all cats are mammals is true. The problem is, though, we don't have true premises, start with false premises. So this is not going to give us a test. We have no idea, even if we know that the conclusion is true, whether that was generated in a valid or invalid manner in the first place. We have to come up with some other things to let these terms stand for. This doesn't work. Suppose we let C stand for cats, E for mammals, T for animals, and we get all cats are animals, all cats are mammals, therefore all animals are mammals. Okay, well, now we have true premises. That's a good thing. Can we make those true premises grind out a false conclusion? Yep, we have. So therefore, that syllogism is invalid. All C or T, all C or E, all T or E. And therefore, the argument all college professors are teachers, so all teachers are educators, college professors are educators. That's not entirely clear, but we can see from this way of breaking it down, using a substitution instance, that, yeah, that is not a valid argument. Even if it may be true that all teachers are educators, that's not a valid argument. The hallmark of invalid arguments, they can yield false conclusions. Even if they have true premises, the truth of the conclusion is not guaranteed. Now, ask the question another way, and this is important. Do invalid arguments always produce false conclusions? And this may be counterintuitive, but the answer to this is no. Life might be easier, or at least more predictable, if the answer were yes, but the problem with invalid arguments, indeed with unsound arguments generally, is uncertainty. It's not that unsound arguments guarantee false conclusions, it's rather they guarantee nothing at all. The conclusions of unsound arguments may be true, they may be false, there's just no way of telling. The guarantee is with a sound argument that its true premises and a valid form combined. That guarantee is that the conclusion must be true, but otherwise all bets are off. Therefore, so long as the argument form is invalid, if you establish that first, does it even matter whether the premises are true or false? No, it doesn't. Even if they're true, the conclusion might be true, but it might be false. There's no guarantee. So this leads to the following general rule. I've stated this before, but now you can see the rationale for it. Check for validity first, check for truth second. Here's why your check engine light, needs to be in order. Why is this? Suppose the form is invalid. If so, then does it matter whether the premises are all true or false? No. Even if they're true, still no guarantee whether the conclusion is going to be true or false. But suppose instead you check, you find the form is valid, then yes, it does matter. You go on and ask the question, are all the premises true? Because if they are, then, but only then, the truth of the conclusion is guaranteed. Necessity. The problem with this is it's counterintuitive. We want to think first about whether the conclusion is. Look at a syllogism and you say, is that conclusion true or false? And the thing to do is to discipline yourself to step back. So you gotta work on making your check engine light come on. It doesn't come on automatically until you train yourself to do this. This involves some relearning. Okay, let's take these examples to illustrate the point. Okay, 3 arguments. Are these arguments valid? All flowers are plants, all daisies are plants, therefore all daisies are flowers. Okay, all Catholics are devils. Jerry Falwell was a Catholic, therefore Jerry Falwell was a devil. Third one, all Catholics are devils. Jerry Falwell was a devil, therefore Jerry Falwell was a Catholic. Okay, now, the first one has true premises and a true conclusion. So maybe the intuition is to say, well, that's probably a valid form of reason. The second one, though, not only is the conclusion false, but premises are false, and the third one likewise. So the intuition there is probably, this is not a good argument. These are not good arguments. Neither of them are. In the first one, the conclusion is true. In the second two, the conclusions are false. Should we therefore predict that the top one is valid and the bottom two are invalid? Note well, you can't answer this question simply by looking to the truth or falsity of the conclusions, or for that matter, the other statements. Well, even though this example can yield a true conclusion from true premises, a substitution instance of its basic skeletal form can also yield a false conclusion. We reduce all flowers are plants, all daisies are plants, all daisies are flowers, to its skeletal form, all A's are B, all C's are B, all C's are A. Well, we get the Michael Phelps example again. Get an example of this exact same form coupled with true premises, but you can make it produce a false conclusion. Therefore, what? Therefore, it's invalid in the Michael Phelps case, but therefore it's also invalid in the flowers and plants case. And therefore, it's also invalid in every other case, no matter what actual content, substantive content you plug in. Okay, what about the second one? Should we predict the second one is invalid because it has a false conclusion? No, because substitution instant shows that it's your Barber syllogism all over again. The same form, all Catholics are devils, Jerry Falwell was a Catholic, is the form we find in all men are mortal, Socrates is man, etc. Barber syllogism, as we know. And in that case, of course, the Barber syllogism, given true premises, can produce a conclusion, will produce a true conclusion. Will not produce a false conclusion if the premise is true. But that's not to say that if your premises are false, it can't produce a false conclusion, or for that matter, a true conclusion. Just looking at the substance of Catholics and devils and Jerry Falwell, etc. Jerry Falwell clearly was not a Catholic, and probably not all Catholics are devils, all of them, and probably not Jerry Falwell. But again, we have to look beyond the substance to the form. And the third one seems kind of similar to the second one, except this case, we don't get the Barber syllogism, we get Michael Phelps again. So the third one is invalid, the first one is invalid, the second one is valid. kind of counterintuitive. Not the pattern that we would expect. So again, discipline yourself to look at validity first, look past the substance, look past the truth value, ask the validity question first, and then you can go on to the substance part, the truth. A couple more arguments. Let's see. Are these arguments valid? Well, let's see. All mules are fish. All fish have hair. Therefore, all mules have hair. Well, let's see. The premises are false, but the conclusion is true. So what do we do? Is it invalid because of the falsity or valid because of the truth? Second example, all dogs are beasts of burden. No men are beasts of burden. Therefore, no men are dogs. Not all dogs are beasts of burden. That's false. No men are beasts of burden. Alas, that is false. Some people are used as slaves. No men are dogs. Well, that seems to be, depending on how you interpret dogs. Okay, well, once again, what do? We don't look to the words, we look to the form, right, in skeletal form. The first one runs all A or B, all C or A, therefore all C or B. The second one runs all A or B, no C or B, therefore no C or A. And we do our dogs and cats, Socrates kind of example, and we see, well, these are both valid in that we can't make two premises produce a conclusion. The first one's kind of easy because it's, again, our barber syllogism again, no, all men are mortals, and etc. The other one, though, we can see by the cats and mammals thing, no cats are mammals, no fish are mammals, therefore no fish are cats. We've not made that argument produce a false conclusion given root premises, so therefore, we call it provisionally. So let's take a common argument from speech order, put it into a syllogism, and then reduce that syllogism and test it for validity using our substitution. Here's the argument I have in mind. Some people argue communism is just really one more form of religion. This is interesting. It's paradoxical in that, well, officially communism is atheist, whereas religions, at least the ones we're familiar with, believe in God. Communism famously follows Marx's citation of Charles Kingsley that religion is the opiate of the people, whereas Marxism offers a scientific analysis of economy and society that, once understood, will lead to a transformative politics and not just drug-like acceptance of the ruling ideologies. So this sort of argument works. If this sort of argument works, it would be very interesting. At least it seems clever. Is communism really just another religion in disguise, perhaps, contrary to what it seems to be? Well, okay, let's put the argument into a syllogism. We could go this way. All religions are things involving belief. Communism is a thing involving belief. Therefore, communism is a religion. Okay. A's, B's, and C's here. All A or B, all C or B, therefore all C or A. We've reduced our substantive argument to its skeletal form. Now we do our dogs and cats substitution instance, and we get the Michael Phelps example again. Here's your same form with content plugged in. True premises, false conclusion. So what do we conclude? Well, it's an invalid form. It's an invalid form in the case of Michael Phelps. So the very skeletal form itself is invalid, and therefore any instantiation of that skeletal form in the case of religion and communism, also an invalid form of reasoning. We're still whole. Okay, now, is it true that communism is just another religion? Well, the foregoing syllogism failed to show how its premises could guarantee with logical necessity conclusion. Doesn't mean the conclusion is false. Doesn't mean the converse is necessarily true. All it shows is that the syllogism itself is not a good argument. It's unsound, at least in virtue of being invalid. But we know that bad arguments, even invalid arguments, might have true conclusions. Might there be another argument, a good argument for the same conclusion? There are a number of other arguments you might be made in favor of thinking that communism, like any other revealed religion, is largely made up of prophecies, as John Mencken says. You go to Red Square, and Lenin's body, after all these years, about a century now, preserved like a medieval religious relic. On the right, so Church of the Alta Petra, the old St. Peter's Church in Munich, and there is the body of Sancta Mundita, Saint Mundita, skeleton dressed in her wedding gown and crown and the whole thing laid out there for the faithful to venerate. What's the difference between Santa Mundita in Munich and Lenin in Moscow? Chairman Mao cultivated a cult of personality. He seemed godlike. Like some religious orthodoxies, communism too has an orthodoxy, punishes heretics who deviate from it. And monks who may have split hairs about angels dancing on the heads of pins have nothing on communist sectarians, for whom a Trotskyist ally is worse than a capitalist class enemy. So, there are a number of arguments one could adduce for the notion that communism is religion. Maybe yes, maybe no. The problem is the argument that communism is a religion because it involves belief. That argument is not a good argument for establishing religion. But beware, this is jumping a little bit ahead to the substance of chapter 3. We're going to talk about fallacies. Beware of what's called the fallacy fallacy. That is, just because an argument, a claim has been badly argued, doesn't mean that there is not a better argument for that same claim. So just because something is arrived at by fallacious, invalid means, in this case, doesn't mean that there aren't valid means to get to this. Not just enough just to detect the fallacy. Doing so doesn't guarantee that the assertion is false, only that it's possible to argue badly for it. But okay, let's shift gears a little bit. And we're going to look at the history of the quarrel between deduction and induction, and in particular, the way in which Karl Popper has a surprising and interesting take on the relationship induction and deduction. So I've titled this From Aristotle to Popper, a brief history of the quarrel between deduction and induction. And here again, we have another Punnett square. Let's cross-classify deduction and induction and their vices and virtues, because it has vices and it has virtues. The virtue of deduction since the time of Aristotle. What's attracted people to deductive reasoning? The fact that you can get ironclad confidence at its best. If and only if the conditions are met, and we know what those two conditions are, valid form, plus all premises true. If and only if that happens, then the conclusion follows necessarily. The conclusion could be no less certain than the premises. That's a very, very strong thing. But in the 17th century comes along Francis Bacon, and he says, look, what's the definition of deduction? It's an argument in which the truth of the conclusion or the content of the conclusion is contained in the content of the premises. Therefore, says Bacon, as a result of that definition, deduction is never going to teach us anything we didn't already know. If you know already that all men are mortal and Socrates is a man, well, you know also that Socrates is mortal. And if you just tease that out by deduction, well, okay, now you've shown something that's true, but you haven't learned anything. That's nothing that you didn't already know. Therefore, he says deduction is going to be problematic, particularly if we, as we are living in an age of science, and in the grand 17th century, of course, we are in a continuing age of science, aren't we? We need to learn new things. So, away from the vice of deduction, Francis Bacon, want to champion the virtue of induction. And that's this. Discovery happens. Discovery proceeds from what we know via experience, and again, by definition, extends beyond experience. That's our definition of induction. So we can learn new things. And if that's what we want to do, if that's what science does, and science does that, it learns new things all the time, not deductive reasoning that's going to get us there. It's only inductive reasoning. But then comes along in the 18th century, first of all, David Hume with his problem of induction. Induction is futile. We can never move logically beyond experience. And to think that we can and call that knowledge is self-deception. It's just begging the question. Reasoning in the 20th century comes along Karl Popper and says, I'll see you and raise you, Hume. There's another vice to induction, and that is this. What passes for induction is actually not a separate form of reason. It is a special form of deduction, and moreover, it is a known bad form of deduction. Induction commits a basic logic fallacy. That's also a pretty strong. Let's see how this works out. Is Bacon correct that science can never learn anything new from deduction? His argument is, since by definition deductive conclusions are already contained in the premises, which they are by definition, Therefore, we can never learn anything new. What he says is two separable things. One is that deductive conclusions are already contained in the premises. Yes, we grant that. Second, the deduction never teaches anything new. Is that second one true, even if the first one is? Well, we can provide a counterexample to Bacon. Remember, a counterexample. We can do so with an example from biology. Paper in Nature more than 20 years ago now. Microbes were found in spores locked in salt crystals. The salt crystals could be dated to 250 million years ago. Therefore, the microbes could be dated to that long ago. Therefore, microbes can survive formation and destruction of continents and mountains and the three mass extinctions that destroyed 95% of all life on Earth. And incidentally, as a third conclusion, therefore, it may be possible for microbes to survive interplanetary travel. So, was life seeded on Earth from outer space? Well, here's a physical basis that suggests that it might be possible. We don't know definitively, but now we have a hunch as to how it could have happened. We think that it could have happened. First two conclusions, notice, are deductive. They tell us something we did not already know. This is against what Bacon says. They do so because premise one is itself a new discovery. Okay, finding microbes in spores locked in salt crystals was not common knowledge until these guys tried it up. The third conclusion is speculative. We don't know that there was interplanetary travel, but now we see that it's at least possible. We can't rule it out. And but Vreeland and Rosenzweig's 250 million-year-old spore suggests a straightforward way in which deduction can produce knowledge, contrary to what Bacon said. It's not all about angels dancing on the head. Okay, fast forward to Popper. Popper wants to argue an even stronger, more general case for the place of deduction in scientific reasoning. Let's look at his trademark view first, that scientists seek neither theory building by induction nor inductive theory testing by confirmation. And here's another one of these little BBC4 things. Turn to the actor.
You might think that scientists begin with hypotheses such as all swans are white and then go about looking for evidence to support them. Karl Popper disagreed. He suggested that scientists do indeed begin with hypotheses, bold hypotheses that can be falsified by evidence. But rather than looking for supporting evidence, Popper argued scientists go out of their way to refute their own hypotheses, testing them to destruction. They go out searching for black swans, not more white swans. Science is all about falsification, not confirmation. It's a series of conjectures and refutations.
Conjectures and refutations, looking for falsification rather than confirmation. Now, go back to Bacon. Since by definition, deductive conclusions are already contained in the premises, we can never learn anything new. Popper says, no, of course you can learn. If you refute a general statement, using modus tollens, for example, this can teach us what's false, and that's often a discovery. In the case of spores, we did learn something new by deduction that we didn't previously know. It's equally possible to learn something new by deduction by learning what we previously thought was true is in fact false, and the whole history of science does that a lot. So yes, by definition, deductive conclusions are already contained in their premises, but it doesn't follow, as Bacon thought, therefore, deduction always just affirms the truth of its major premises. The premise itself is new, and sometimes the deduction denies the major premise, part of the major premise. One could deny the consequent in particular. Bacon thought, secondly, discovery proceeds from what we know via experience, and again, by definition, extends beyond experience. We can learn new things. Popper says this, and I'm quoting from him, a scientific theory is never inferred in any sense from the empirical evidence. There is neither a psychological nor a logical induction. Only the falsity of a theory can be inferred from empirical evidence, and this inference is a purely deductive one. So historically, we've distinguished in philosophy between deduction and induction. The thought of logic is of one of the two kinds, but Popper says no, there isn't really induction. There's neither a psychological nor a logical induction. Induction is hereby abolished, at least if Popper has his way. And here's a real tour de force for saying this. Induction is really bad deduction, okay? Take our swans again. On the standard view of scientific induction by enumeration, we looked at that in the previous. Piles up numerous individual observations from enough concordant observations. Swan is white, that swan is white, n swans are white. One induces generalization, amplitude generalization, all swans are white. Popper points out we can reformulate this process into n number of conditional syllogisms, their enumeration together supporting the same conclusion. So we would say, for example, in syllogistic form, conditional syllogism, if all swans are white, then each swan is white. And so I go around looking at swans and I say, oh, here's a swan that's white. Swan 1, swan 2, swan 3, swan n, whatever the number n is white. Therefore, collectively, I say all swans are white. You can simplify this syllogism in the following way. If A, then B, 1 through n number of times, and therefore A. Well, have we seen this before? Yes, we have. What is this except affirming the consequent? It's a known deductive fallacy. A is the antecedent, B is the consequent. If I take a conditional statement, if A, then B, and then my minor premise affirms B, what am I doing? B is the consequent, I'm affirming the consequent. Seen this before. Therefore, major conclusion. Not only is induction not a separate form of logic, it's merely a form of deduction, and it is a known bad form of deduction. Well, that may seem depressing. Popper says, don't worry, because in fact, scientists don't set out to find numerous confirming observations. They look for those black swans, they look for the disconfirmation. They start with a prior generalization of theory, and then they derive conditional consequences from it, such that the antecedent is a theory, the consequent is a testable hypothesis. Then they search for disconfirming observations. They search for modus tollens, in other words, that counterexample, at least one non-white swan. So basically, they take the theory that all swans are white, and they try to shoot it down. And again, this is what induction amounts to. The theory that all swans are white, the hypothesis each swan is white. But this is the known invalid deductive form, affirming the consequent. What scientists actually do is modus tollens. This is a known deductive form also, but it is a valid form. If all swans are white, then each swan is white, but this swan is not white. Instead of asserting B, affirming the consequent, they deny the consequent, therefore deny the antecedent theory from which the consequent, which is the hypothesis is derived as a consequent, and refute the theory. So it looks bad for from one standpoint for the logical prospects of induction, but Popper says not to worry. Induction really isn't a big thing in science at all. It's not a separate form of logic at all. It's really deduction, a known invalid form, the fallacy of affirming the consequent. There is neither a psychological nor a logical induction. We only infer the falsity of a theory, never the truth of it. If two wrongs don't make a right, neither do n wrongs. If it's wrong to affirm the consequent once, then it's wrong twice. It's wrong n times, whatever number you have. Science progresses not by adding confirmations, but by subtracting disconfirmations. Fortunately, again, as Popper notes, science doesn't rely on induction in the first place. It tests theoretical generalizations by a known valid form called modus tollens. That is to say, it makes theory A produce conditional consequence B. Then it attempts to show the minor premise in a deductive conditional syllogism to be false, that is the not B bit, thus refuting theory A and subtracting it from the population of generalizations might be possibly true. Okay, now we're at a point to sum up what's been said about truth and validity, substance and formality, and so forth, and then to move on to our next topic, which will also be in two parts on language and logic. Let's sum up first. Truth is substantive, validity is formal. Remember, no statement is ever valid. Substantive claims are true or false. Truth value is a property of each individual statement. Validity is a formal property, property of the argument as a whole. In argument, it matters both what you say and how you say it. Validity is about how you say it. Truth is about what you say. Think of validity like reliability. Validity is like pregnancy. It's not relative. Can you be 99% pregnant? No. You can't be 99% valid either. If an argument is valid, it's always valid. If an argument is invalid, it's always invalid. Think of it like theft. If you come to my house 99 times and don't walk out with a silverware, and the 100th time you walk out with my silverware, you're not coming back 101st time unless you're going out feet first. Once a thief, always a thief. And arguments are like that. Once invalid, always invalid. Once it fails, doesn't matter how many successes it might have had. That one dreaded counterexample, it's all it takes. And if you can show of an argument form that it's invalid, how do you do that? You can make true premises produce a false conclusion, even if only once. All you need to do is once, because thereafter that argument form is invalid in any application whatsoever. You don't have to reevaluate its content all over again, which is, a good reason to get familiar with some of these invalid arguments in particular. Recognize, affirming the consequent. What did I say about that? It's the single most common deductive fallacy. You'll see it a lot. You see it, obviously if Popper is right, you see it a lot in attempted induction. We looked at 3 types of syllogism. Notice, by the way, that what distinguishes the 3 types of syllogism are the respective major premises. We looked at the disjunctive, the categorical, and the conditional. The disjunctive syllogism has a disjunction, its major premise. And again, the disjunction we're using is the exclusive, not the inclusive. We're using the either or. Conditional syllogism has a condition as its major premise. Condition, it's an if-then statement. And it has antecedent and consequent bits of the statement. The categorical has a categorical statement. That's its major premise. This example has all A or B, but it could be no A or B. It could be some A or B, or it could be some A or not B. We'll pick up in chapter 5. But you can tell right off the bat by looking at the major premise what kind of syllogism you have. And again, check engine light should come on. Any term which appears in the conclusion must have first appeared in one of the premises. So if you find not B in the conclusion of your disjunctive syllogism, check and see if there's a B somewhere in at least one of the premises there is. The conditional likewise, the categorical likewise. The categorical, you're going to find the letter C as well as A and B. Your check engine light again should come on if you find yourself sticking extraneous letters into the disjunctive. If you find yourself sticking in any more than 3 letters in the categorical, again. Syllogisms are technical. However, any resemblance between a syllogism and algebra is merely superficial. Both use placeholder terms, for example. But notice, in none of our syllogisms is there an equal sign. What is that? There's no equation being stated. We're not, even when we're saying that something in one category belongs to another category, we're not saying that those categories are analytically identical. Notice these are 3 different types of syllogism. None of them has an identity statement. There's no equal sign anywhere, not even the categorical. Okay, if I say all albatrosses are birds, I'm not asserting that the meaning of the category albatross is analytically identical to the category bird. I am asserting merely a synthetic proposition. There is a contingent relationship between being an albatross and being a bird. Those members of the category albatross are also members of the larger category bird, for example. Now, it may sound kind of simple or maybe even silly or stupid to say this, but here's why I say it. It's an example from an actual exam. Please do not find yourself in this situation. If A is B, C equals D, B equals E. What does that mean? This is clearly done by someone who has glanced at the page, maybe paid a little attention to the lecture, but has not worked through pencil and paper syllogism. Okay, work through pencil and paper the syllogisms, you will eliminate this kind of mistake. And if you know, this is likely the kind of thing you're going to show up with. So don't make the baby Jesus cry. Don't make Mr. Khrushchev reach for his shoe and pound it. No, yet. Do your work, get prepped, work through these syllogisms, and you'll be fine. Thoroughly walk yourself through table 1.1. Remember, I said that's the single most important page of this entire bloody book. And quiz yourself, ask yourself the question, can true premises ever produce false conclusions? Can I find examples on this table in which they do? Yes. Do invalid arguments always produce false conclusions? No, sometimes they can produce true conclusions. I can see that on the table. Can a valid argument ever produce a false conclusion? Yeah, I can find an example. Can a valid argument ever be unsound? I can find an example, and so on and so on and so forth. And if you can walk yourself through this table, with that kind of quiz in mind, then any question that I give you on an exam is not going to be a surprise. So that's a good study technique there. In closing, the Neoplatonists before retire interpreted Aristotle's logic of genus and species in the form of a branching tree. We could do the same sort of thing here with respect to logic. Okay. You hear a sound. Either the sound is speech or it's noise. If it's noise, it's nonsense. Don't worry about it. Otherwise, it's in the realm of sense. Now, if people are speaking, sometimes they are making an argument, but sometimes they're not making an argument. That doesn't mean that the use of language is illegitimate. The argument is not the only use of language. Lots of things you can do that are logical, that aren't argumentative. Talked about that in the early lecture. But if you're dealing with something which is argumentative, now you cross the boundary from simple sense to logic, which is a kind of sense, but of its own in its own form. If you're dealing with an argument, you got to decide: is it inductive or is it deductive? Now we've just seen Popper's argument that there is in fact no such thing as inductive logic, but we're not so concerned with that in this course. We're doing deductive. If you encounter deductive argument in logic, you've got to make a basic decision. Is the form valid or is the form invalid? And that's the first decision you want to make. Remember, ask the validity question first. Now, if the form is invalid, walk away. Nothing more you can do with it. Even if the premises are true, you don't know what the conclusion is going to be. But should you decide your form is invalid, you have a further decision. Are the premises true or are they not all true? Two premises, all premises. More complex argument. If you decide that they're not all true, walk away, because even if the form is valid, you don't know whether your conclusion is true or false. But if you decide you have a valid form and you discover that all your premises are true, then you can stop, because then you know something. You know something important. You know your conclusion is true. Okay, and that brings us to the end of the general considerations. With that under our belts, we're ready to move on to a consideration of logic and language, which we'll do in chapter 2. And go ahead and read chapter 2, sections 2.1 and 2.2, and then we'll begin to take that up in logic lecture. Thank you for listening. This is Michael Cavanaugh. Good day.